right, we are now on anatomy lesson 10.06 on ion channels. And we said in the last video that ion channels are passive transport. So we're talking about, first of all, let's go back over our definition of ion. So an ion is an atom with a charge. And we should be a little bit specific about, we already talked about 2 videos ago which atoms with charges we're talking about. So we're talking about sodium, got a +1 charge. Potassium has a +1 charge. We're not using it very much in this chapter, but calcium is +2, chloride is -1. And the two that we are going to be focusing on the most are sodium and potassium. And what we're going to see is that active transport also transports sodium and potassium, but in this case, when we talk about ion channels, we're talking about the passive. And what that means, what we said is if we have more particles outside the cell than inside the cell, well, actually, let's start down here. Okay, so there are 3 different ways to get an ion channel open, but one possibility is you have an ion channel that's just always open. It's basically a hole in a protein with a hole in the middle. Here we have that phospholipid bilayer. So we've got our phospholipid bilayer. And then we have a protein embedded in it. And this protein channel here in dark green is an always open, protein ion channel for potassium, and this one's for sodium. And if there is more sodium outside the cell, so if we get a buildup of sodium, because I have a higher concentration out here, so here I have a higher concentration, and let's say I've got just a few on the inside. So this is outside the cell, and this is inside the cell. Because I have a higher concentration outside than inside, I will get sodium ions that flow through into the inside of the cell until the concentrations are equal. So these rely on concentration gradient. So ion channels on a concentration gradient. And once there's no concentration gradient, the flow stops. And this happens, we said it happens automatically. So what we want to investigate in this video primarily is how do these, if they're not always open, how do they get open? Well, isn't it just they open? Well, think about it. You go through doors all the time. How many different ways can you think of that you can open a door? And don't just think about your home. Think about other places that you go. So take a second. So maybe you said you're going to turn a doorknob. Turn a knob. What about, did any of you say in hotels, you have a key card that you put into a slot? Some of you put a card into a slot. That opens a door. What about if you go to the grocery store and you have a sensor door? And that's an electronic sensor, by the way. So you just got into 3 different buildings, 3 different ways. Ion channels, membrane protein ion channels are the same way. They come in ligand gated, mechanical gated, and voltage gated. This is like turning a knob. This is like using a key card, and this is like going through with a sensor. And we're going to talk about each of these and how they work. So for these on the right, you have a closed a protein, and on the left you have an open protein. So here's closed, here's open. Here is closed and here's open. So let's start off with mechanical gated. What we have happening here is you have pressure. So we get pressure on the membrane, and that pressure causes this closed ion channel to open. So a mechanically gated ion channel opens in response to physical pressure. Just like you can open a door by turning a knob. So applying pressure, it opens up the membrane. And then if you have more stuff outside the membrane than in, you'll get flow. If you have pressure and things are equal, nothing will happen. So again, we're only talking about how does that door get open. All right, well, let's go to ligand gated next. And you'll notice here it says I have a receptor. So on a ligand gated membrane protein, we have receptor sites. And I'm going to kind of outline those in black. When a substance binds to these, it opens the door. So for a ligand gated membrane protein, a substance binds to the protein, causing it to open. And you'll notice here, they talk about that substance being a neurotransmitter. And we've seen this before. We talked a little bit about this. So we've got a closed membrane protein. All of a sudden, acetylcholine binds to the membrane protein and it causes it to open. And then once it's open, we get passive transport through. The last one, and so this one we're not going to really have in this chapter at all. This one we're going to have a little bit, and the third one we're going to have a lot. So for voltage gated, you'll notice it's blocked on this side. So there's something that's blocking it here. So this is closed. And we have a voltage. Kind of like we do with batteries. So we've got a positive voltage here and we've got a negative voltage here. If something comes along and causes that voltage to change, so all of a sudden, this positive voltage goes to a negative voltage and the inside negative becomes positive. This voltage change, and I can't say color coded because this one's yellow and I can't write in yellow. So I'm going to go with green. So we have a change in the membrane voltage. Opens the protein. This is like the electronic sensor. When you go into Walmart, you break a beam with your ankle and it sends there's a voltage shift and that triggers a current and that causes the door to open. So at rest or starting out, we're here, but then there's a change. So if we use the term voltage gated ion channel, we're talking about this. If we talk about a ligand gated ion channel, we're talking about one that opens because something binds to it. If we talk about a mechanically gated ion channel, we're talking about an ion channel that opens in response to pressure. But let's just do this on our takeaways. So what are our takeaways? We are looking at ion channels that are proteins that are inside of cell membranes, and they always operate. These particular membrane proteins operate off of passive transport, which means if there's more stuff outside, it'll go to the inside. The way that they open, though, can be one of three ways. They can open in response to pressure. It can open in response to something binding to them, in which case they're called ligand gated, or they can open in response to a change in voltage at the cell membrane. So we have a positive voltage here and a negative here. If that flips, it's going to open up the channel. That's called a voltage gated ion channel. So the two terms that you're going to see over and over are ligand gated ion channel and voltage gated ion channel. And this was your explanation for what those are. All right, that'll do us for 10:06. The next one, we're going to do sodium potassium pump, which also transports ions, but it does it actively. There's no more passive transport when we're talking about the sodium potassium pump. All right, that's all for now.